Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Unit 4, Lesson 5. The lesson is called Applications of Proportionality in a Circle. In this lesson, inshallah, we are going to study some relations related to the circles. Some of them we already studied in this term in lesson 5, the last unit, and some of them we have studied in the third prep, and some of them are new. This lesson, inshallah, will be the last lesson in the geometry in this term. Let's start the lesson. Now we are going to study a concept called power of the point A with respect to the circle M, which denoted by PMA, or power of A with respect to the circle M. Okay, this relation controls the position of the point A with respect to the circle M. Okay, for example, if we have a circle M and we have a point A like this. Okay, if we connect between A and M, then the distance A and M is the distance between the point and the center of the circle like this. And the distance between M and the circle is called R, or the radius of the circle. Okay, what is the power of the point A? The power of the point A is a relation equal AM all power of 2 minus R power of 2. Again, PM of A equals AM power of 2 minus R to the power of 2. By looking to this one, you see that AM power of 2 minus R power of 2 may be positive, may be equal 0, and may be negative. Okay, this is depend on the length of AM and R. If AM is greater than R, so in that case the value is a positive, and if AM equal R, so the value equals 0, and if AM smaller than R, in this case the value is negative. Okay, the first case, as we see here, A is lie outside the circle, so AM greater than R. In that case the power of the point A is positive. A here is outside the circle, and the power of the point A is greater than 0. In the second case, if A belong to the circle like this, in that case AM equal to R, so the power AM power of 2 minus R power of 2 equal 0. So if A is on the circle, so power of the point A equal 0. And the last case, if A is inside the circle like this, now AM is smaller than R. Again, AM is smaller than R. So the difference, this difference will be negative. Now here AM is smaller than R, so if A is inside the circle, so P of A, or power of the point A with respect to M, is smaller than 0. Finally, or briefly, if PA greater than 0, so A is outside, PA equals 0, so A belongs to the circle, and if PA less than 0, so A is inside the circle. Okay, let's start the first question. Find the power of the given point with respect to the radius M. Okay, here AM equal 12 and R equal 9. Okay, now if I need to draw, but it's not necessary. Okay, now this is the point A and this is M. Okay, now R equals 9 and AM equal 12, so this part equal 3. Okay, now if I need to evaluate P of A with respect to M, written like this, power of A with respect to the center M or the radius to the circle M. Okay, PA here equal A M all power of 2 minus R power of 2 equals 12 power of 2 minus 9 power of 2. This is equal 63, and it's clear that PA here is positive and A is outside, and this is clear from the figure. And the other one, P of B, BM equal 8 and R equal 15, so P of the point B with respect to M equal BM power of 2 or 8 power of 2 minus R power of 2 or 15 power of 2. It's equal negative 161, because P of B is negative, so that means B is inside the circle. Okay, the next question. Determine the position of each of the following points with respect to the circle M of radius 10, and then calculate the distance between the point from the center of the circle. Okay, here P of A is negative, so A is inside the circle because P of A is negative. Okay, now to evaluate AM, so I'm going to write the rule here. P of A with respect to M equals AM all power of 2 minus R power of 2, so negative 36 equals AM power of 2 minus R power of 2. Now I'm going to send this one to the other side with a positive value, so AM power of 2 equal negative 36 plus 100, it's equal 64. So AM equals root 64 equal 8 centimeters. Root 64 equals 8 centimeters. Okay, number 2, P of B equals 96. Here B is outside the circle. Why? Because the value of P of B is positive. Okay, outside the circle, and P of B with respect to M equal BM power of 2 minus R power of 2, so 96 equals BM power of 2 minus 100 or 10 power of 2. I'm going to send the negative 100 to the other side plus, so BM power of 2 equals 96 plus 100 equal 196 by taking the square root, so BM equals root 196 which is equal 14 centimeters. Number 3, question 3. If the distance between the point and the center of the circle, let this point is A, so PA, so AM equals 25, and the power of the point P of A equals 400. So I need to evaluate the radius. Okay, here P, this is the rule of A equals AM power of 2 minus R power of 2. Okay, now 400s equals 25 all power of 2 minus R power of 2. Okay, now I'm going to send R in this side and 400s in this side. So R power of 2 equals 25 power of 2 equals 625. By sending 400 to the other side, it will be minus 400s. So R power of 2 equals 225. By taking the square root, so R equal 15 centimeters. Now let's study the relation between power of the point A and the relation between chords and secants as we studied in lesson 5 unit 3. Okay, now if we have a point A and this point outside the circle M like this, we have circle M and we have a point A such that A belongs to outside the circle M. Okay, if we draw a secant from A to the circle like this, in which this secant intersect the circle at B and C, and now BM is called radius and CM is called also radius. If I draw a tangent from A like this, okay, now we have a tangent and a secant. Okay, remember with me, P of A with respect to M equal AM power of 2 minus R power of 2 like this. P of A with respect to M equal AM power of 2 minus R power of 2. This is a rule that we studied before. Now we have here difference between two squares. I can factorize this one into two brackets, AM minus R and AM plus R like this, AM minus R and AM plus R. Okay, the square root of AM power of 2, AM minus plus R power of 2 will be RR. Okay, now AM minus R. By looking to AM, this is AM from A to M. If I subtract R from AM, then the remainder will be AB. And AM plus R. If I have AM and plus R, this is also R, it gives me AC. So that one equals AB and that one equal AC. Finally, I can guess that power of the point A, this is a new rule, equal AB times AC. AB times AC. AB times AC, I already studied this one at lesson 5 unit 3. AB times AC equals AD power 2. Again, AB times AC equals AB times AC equals AD all power of 2 like this. Finally, I can guess that this rule, power of A equal AB times AC equal AD power of 2. Oh, okay, this is AD. Okay, power of A equal AD power of 2. So AD equal root power of A. So root power of A gives me AD. Okay, finally, power of A equal AD power of 2 equal AB times AC. This is very important rule. I make a connection between the rules AD power of 2 equal AB times AC that I studied in lesson 5 unit 3 and this the new rule power of A. So power of A equal AD power of 2 or equal AB times AC. Okay, now what will happen if A is inside the circle? It will be like this. Here A, and I'm going to connect like them, like this. Here MA is smaller than R. Also, power of A equal AM power of 2 minus R power of 2 like this. And I'm going to factorize AM minus R, AM plus R. but AM is smaller than R. I can't subtract AM minus R. Actually, I can't subtract AM minus R. So I'm going to switch this bracket to be R minus AM, but I'm going to change the sign of this bracket like this, negative R minus AM. Okay, because AM is smaller than R. R minus AM. Now this is R from M to B. By subtract MA from R, it gives me AB, and MA plus R, it gives me AC. Like this, negative AB times AC. Finally, P of A equal negative AB times AC. That's if A is inside the circle. Here it's positive because A is outside, but here it's negative because A is inside. Okay, now if I have another chord like this, so this is what we studied in lesson 3, the previous unit. Power of the point A equal BA, A times AC, but negative, and it is equal AD times AE in negative, like this. P of A equal negative AB times AC, or equal negative AD times AE. Again, power of the point A equal negative AB times AC, or equal negative AD times AE. This is a very important rule. Let's study the next question. The radius of length of the circle equal 31. So we have a circle, its radius equal 31. So I'm going to draw the radius like this. The radius here equal 31. Let this point is called E, for example. Okay, now the point A lie at 23 centimeters from its center. From the center here there is 23, so 23 is less than 31, so A probably here in this position. Okay, in which this point equal 23, this distance, and this distance equal 31 minus 23 equals 8. Okay, now draw BC such that A belong to BC. I'm going to draw line segment BC passes through A like this, in which this is AB is greater equal 3 AC, so AB greater than AC, so this is B, the bigger part, and this is C, the smaller part. AB triple AC. Okay, 1, 2, 3, and here 1. Okay, calculate the length of BC. Calculate the length of BC. Okay, now, as we studied last time, let this one called X. So, this part equal 3x. Okay, now, by looking to this one, AE times AM equal AC times AB. Again, power of the point A, here R equal 31, and power of the point A with respect to M equals AM power of 2 minus R power of 2, which is equal AM 23 power of 2 minus 31 power of 2, that's equal negative 432. Okay, now by using the previous rule, P of A equal CA times CB, again but in negative. Here P of A with respect to M equals negative CA times AB. Okay, therefore negative 432 equals negative CA is x and AB is 3x. X times 3x equals 3x power of 2, so it will be 3x power of 2. Now I'm going to send cancel negative and send make divided by 3, so x power of 2 equal 432 divided by 3 equals 432 divided by 3, 4 divided by 3 equal 1, and 13 divided by 3 equal 4, 12 divided by 3 equal 4. Okay, so x power of 2 equal 12, therefore equal 144. So x equal root 144 equals 12. Now AC equal 12 and AB equal 3 times 12 equal 36. Okay, therefore CA equals 12 centimeters. This is the first part of the question. The second part, if the distance between the chord BC and the center, find the distance between the chord and the center. Okay, now I don't need those anymore, so I'm going to erase them. Between M and the center and the chord will be like this. This will be perpendicular distance. Okay, now remember with me, CA equal 12, this is A, CA equal 12, and AB equal 12 times 3 equal 30, CA equals 12 and AB equal 36. Okay, this is what we solved the last in number 1. Okay, here the perpendicular from the center bisect the chord, so this is the midpoint of the chord. Okay, this part is the midpoint of the chord. Now CB equals 12 plus 36 equals 48. Now I'm going to divide 48 divided by 2, so this one equal 24 and this one also equal 24. So this point, if this point equal F, so AF equal 12. Okay, now AM equal 23. It's easy to find MF by using Pythagorean theorem. Therefore MF equals square root 23 power of 2 minus 12 power of 2. It's equal 19.6 centimeters. The next question. Now we have example 5. In this example, in the opposite figure, M is the circle, AB is a diameter, as we see. CB is a tangent to the circle M at B. CA intersect the circle at D. CD 16, DA equal 9. Find the length of the radius and find the area of triangle ABC. Okay, first I need, this is a tangent, so this angle is right angle. Okay, by using the previous rules, since CB is a tangent, therefore CB to the power of 2 equals CD times CA. Again, the tangent power of 2 equals CD times CA. Okay, So it is equal 16 times CA equals 25. So it is equal 400. Okay, by taking the square root, therefore CB equal square root 400 equal 20. Now this part equal 20. Okay, now I can find AB by using Pythagorean theorem. AB equal square root 25 power of 2 minus 20 power of 2. This is equal 15 centimeters. Okay, AB is a diameter, therefore R equal 15 divided by 2 equals 7.5. Now the radius equals 7.5. Finally, area of triangle ABC equals half times base, which is base times height, equals half times 15 times 20 equals 150 centimeter squared. The next question. Now we have in this example, AC is a tangent, as we see. AD equals 8. Okay. EF equal 18. Okay. And P of A with respect to circle M equals 144. P of A, okay, equals 144. Find AC, DB, and AE. Okay. For easier, I'm going to call this one X, and I'm going to call this one Y, and I'm going to call this one Z. Okay. BDZ. Okay. Now P of power of the point A with respect to the circle M, since equal A C power of 2, so it is equal Y power of 2. Therefore Y power of 2 equals 144. Therefore Y equal root 144 equal 12 centimeters. So AC equal 12 centimeters. Therefore AE times AF equals AC power of 2. Therefore therefore 12 power of 2 equals AE equals X, and AF equal X plus 18. I'm going to distribute X times X equal X power of 2 plus 18X equals 144 by sending 144 to the left side. So X power of 2 plus 18X minus 144 equal 0. By using the calculator, so X equals 6, mode equation 3, and X equal negative 24, negative 24, but this is refused. This is refused, so X equal 6. So AE equal 6. Finally, if I need to find Z or BD, here AD times AB equals 12 power of 2. So 8 times 8 plus Z equals 144. I'm going to send 8 there divided, so 8 plus Z equals 144 divided by 8, it's equal 1, and 64 divided by 8 equal 8, so it is equal 18. By sending 8 to the other side minus, so Z equal 10. Okay, now this is the first required. The first required, I found AC equal 12, AC equal 12, AE equal 6, and BD equal 10. Now I'm going to erase the screen to solve part number 2. X belongs to BD, okay, such that dx equal 4. Okay, here the point X, such that dx equal 4. Since dx equal 4, so bx equal 6. Okay, find the power of m with respect, power of the point X with respect to m. Okay, here power of the point X with respect to m equal xd negative, sorry, xd times xb. So it is equal negative 4 times 6 equals negative 24. This is the second part of the question. Now let's study the principal axis. What is the principal axis? Let we have two circles like this, M and N. Okay, those two circles intersect at the 2 points A and B. If we have a straight line passing through A and B like this, and we have a point C belong to this straight line, so if I need to evaluate power of the point C with respect to M, it is equal CA times CB like this. And also if I need to evaluate power of the point C with respect to N, it is equal also CA times CB like this. By looking to the two cases, power of C with respect to M equal CA CB, and the power of C with respect to N CA CB. So the two powers in the two cases for the same point are equal. So C belong or lie on the principal axis if the two circles M and N, if P of power of the point C with respect to M equal power of C with respect to N. This is the way to prove that this is a principal axis. Okay, now let's solve the next question. Now we have example 7. Two circles M and N intersect, touching externally. Okay, now I'm going to draw two circles touching externally like this at the point A. So this point is A. Okay, AB is a common tangent, so I'm going to draw AB common tangent like this, in which this is the point B. Okay, to the two circles M and N, BC intersect. This is the circle M, for example, and this is the circle N. Okay, now I'm going to draw BC intersect circle M at C and D. So this is C and this is D. BE intersect circle N at E and F, E and F. Okay, prove that AB is a principal axis for the two circles M and N. Okay, to prove that BA BA is a principal axis, so I'm going to evaluate P power of B with respect to M equal power of B with respect to M equal BA power of 2. And power of B with respect to N also equal BA power of 2. Therefore, P of B with respect to M equal P of B with respect to N. Therefore, AB is the principal axis for the two circles. Okay, this is the first part of the question. The second part, if P for the point B equal 36 and PBC equals 4 and EF equals 9, so evaluate BC equals 4, so evaluate CD, AB and BE. Okay, first, power of the point B equal 36, therefore BA to the power of 2 equal 36, therefore BA equals square root 36 equals 6. So this part equals 6. Okay, now I'm going to call DCX and BEY. Therefore, 4 times 4 plus X equal 6 power of 2, which is 36. Therefore, I'm going to send 4 divided 36 divided by 4 equals 9, so 4 plus X equals 9. I'm going to send 4 minus, so X equals 5. This is X equal 5. The other part, here Y, I'm going to solve it here. Y times Y plus 9 equal 6 power of 2. So Y power of 2 plus 9Y equal 36. Send 36 negative. So Y power of 2 plus 9Y equal minus 36 equal 0. Okay, now Y equal 3 or Y equal negative 12. This one refused, so Y equal 3. So BE equal 3, and this is question 7. The next one. Okay, in this example, two circles M and N intersect at A and B. XD equal double DC. XD double DC. So, for example, if this one X, DCX, so XD equal 2X. Okay. Now, and EF equals 10. First, prove that and Px equal 144, Pn for the circle n, power of the point x for the circle n equal 144. First, prove that AB is a principal axis. Okay, since P of the point x with respect to m equal xb times xa. Okay, and power of the point x with respect to n also equal xb times xa. Therefore, ax or ab straight line is the principal axis. Okay, this is number one. Number two, find xc and xf. Okay, here power of x with respect to n 144. Therefore, start with n. I'm going to call xf y. Therefore, y times y plus 10 equals 144. So y power of 2 plus 10 y minus 144 equal 0. So in that case, y equal 8 or y equal negative 18. This is refused. Okay, so y equals 8, so this part equal to 8. Okay, now xf equal 8. The second part to find xc. Here xd times xc equals also 144. So 2x times 3x, because xc equal to x plus x equals 3x equals 144. So 6x equals 140, x power of 2 equal 144. So x power of 2 equal 144 divided by 6 equal 24. So x equal, by taking the square root, equal 2 root 6. This is the value of xc equal 2 root 6. Okay, this is the second part. Prove that CDFE is a cyclic quadrilateral. Okay, now to prove this one is a cyclic quadrilateral, let's erase the screen. Remember with me, this is the line CDFE. Prove that this line, this quadrilateral, is a cyclic quadrilateral. Okay, we studied before, if we have a point outside quadrilateral, if xd times xc equal xf times xe, so this part is a cyclic quadrilateral. Okay, since x belong to principal axis, therefore P of x with respect to m equal P of x with respect to n. Therefore xd times xc equal xf times xe. Therefore fdce is cyclic quadrilateral. Okay, now let's remember some well-known problems. The first two well-known problems we have studied in the first and the third prep. Number one, if we have a circle like this called circle M, and if we have two intersecting chords like this at the point E. Okay, so E, here we have four angles. For example, if I take angle DEB like this angle equal to its opposite, which called VOA. Okay, now by using the circle, we can find the measure of angle DEB, which is equal half the two subtended chords arcs DB and AC. So angle DEB equal half measure of arc AC plus measure of arc BD. AC and BD again, AC, the two subtended arcs. Okay, if the angle is outside the circle, if have, no, this is number two, a circle like this, and we have two intersecting secants, okay, they form an angle outside the circle. This angle equal half the difference between the subtended arcs AC and BD. So measure of angle E equal half AC minus BD, AC minus BD. So if the angle inside the circle, it's equal half the sum. If the angle outside the circle, equal half the difference. Okay, two other rules related to the last rule. Okay, the last rule was two secants. If we have now tangent and the secant, tangent, this is the tangent and the secant. Also they have an angle between them called angle E. It's equal half AC minus BC. E equal half AC minus BC, as we see, AC and BC. Also, if we have two tangents, they form an angle like this between them. This angle equal half arc ACB minus AB. E equal half ACB minus angle B. But remember here that angle arc ACB plus arc AB equals 360. Let's solve the next questions. Okay, example 9. Using the given data in each of the following figures, find the value of the symbol used in measure. Okay, number 1, x here inside the circle, so x equal half 60 plus 100. X equals half, open brackets, 60 plus 100 equals 80 degrees. Number 2, x outside, it's equal half 70 minus 30. So x equal half, open brackets, 70 minus 30 equals 20 degrees. Number 3, x is outside also, so x equals half, open brackets, 150 minus 70 equals 40 degrees. And here x is outside also, but first I need to find BC. This one equals 360 minus 120 equal 240. Again, BC, the measure, equals 360 minus 120 equal 240. So x equals half, open brackets, 240 minus 120 equal 60 degrees. Number 5. Okay, 5 and 6 appears together, it's okay. Here I can make an equation. Angle A, or 28 degrees, equals half, open brackets, x minus 30. First, I'm going to send half divided, so x equal minus 30 equal 28 divided half, again 28 divided half equals 56, and send 30 there plus, so x equal 56 plus 30 equals 86 degrees. Okay, now also by the same way, angle 50 equal half, open brackets, 145 minus 2x minus 5. I'm going to send half divided, so 145 minus 2x minus 5 equals 50 divided half equals 100. Okay, now I'm going to send 145 minus, so negative 2x minus 5 equal 100 minus 145 equal negative 45. Cancel the negative and send 5 plus, so 2x equal 45 plus 5 equals 50, and send 2 was divided, so x equal 50 divided by 2 equal 25. Number 7, here we have also, this is a circle, so this one equal 360 minus 2y, so 50 degrees equal half, open brackets, 360 minus 2y minus 2y. I'm going to send half divided, so 360 minus 2y equal negative 4y. 50 divided half equals 100. Okay, now I'm going to send 360 minus, so negative 4y equals 100 minus 360 equal negative 260. Cancel the negative and divided by 4, so y equal 260 divided by 4 equals 65 degrees. Okay, here number 8. It's complicated. I can't find x and y in the same time, x, y, and z. Okay, I'm going to divide this one into two cases. In the first case, I'm going to find x. Okay, here to find x, 15 equal half, open brackets, x minus 60. I'm going to send half divided, so x minus 60 equals 15 divided half equals 30. So send 60 there, so x equal 30 plus 60 equals 90. This is the value of x. Okay, this is 90. Okay, now I can find y. Y equal, the circle equals 360. So 360 minus 140 plus 90 plus 60. So y equal 360 minus 140 plus 90 plus 60 equals 70 degrees. Again, 360 minus 60 plus 90 plus 140 equals 70. So y equal 70. Finally, z equal half, open brackets, 140 minus 70 equal 35 degrees. And this is the end of the lesson. I hope it was helpful, and this is the end of the term. I hope it was useful for you. See you inshallah in the revision and in the next term. Assalamu alaikum wa rahmatullah wa barakatuh. Mr. Ahmed Mahmoud was with you.